Hey there, guys, and welcome back. So, let's see. We will start out here, I guess, just to get it out of the way. If you did not watch my stream earlier today on linear slide rails, you probably should. That has a lot of information in it. But at the end of the stream, I was talking about what we are going to end up doing since it made less sense to do. Do I still have it open? It doesn't look like I do. To do the actual MGN style linear block bearings. And we were going to try something a little different. For that, we needed these LM8UUs in the open configuration. Did some more research. This is the ones I told you about that I had found where they were actually cheaper to get them open instead of closed. But as it turns out, these are literally the only ones I can find online. Evidently, in this size at the LM8 level, at the 8mm ID level, nobody really wants to make these, I guess. So it's just plain extremely difficult to get them. And to begin with, these are, as you see, $5.39 a piece, whereas normal LM8s are $2 for expensive ones, $1 for cheap ones. And it's a quantity 10 minimum. I tried putting it in a smaller number, does not work. So this is actually a pretty expensive investment to get these in. But we'll still go ahead and do the design for this kind of rail system, but I'm probably not going to bother printing anything out for these guys, just to give you a heads up. In other news, I was looking at the V groove bearings, and again, as I mentioned, I noticed in the picture of the block that we were looking at that the sides looked more curved than this. And as it turns out, I found out, going through some links on Amazon, that they actually make U-groove bearings as opposed to V-groove bearings, which is probably what was on there. So one of these things, there's a few different kinds. They're all steel, it turns out, and they're all actually not terribly priced, So they're actually quite cheap, which is nice. At this scale, one of those things. At this scale, obviously, these are 4mm IDs are the ones that I'm picking out, which means that they are smaller. They're more comparable to my 623s. You can see this one actually says 624. So it's the same class, the same rough size as the really small 623s that you've seen me use before, but they've got these U-grooves in here. In other along those lines, I already said in other news. Along those lines, this U-groove right here on this specific model, you can see it says that's 5.2, so that sounds too big to me. The depth on it is only 1.8, so it may not be too big. However, I'm pretty sure that is too big for the 5mm rods that we were looking to use, because that should introduce slop up and down, like perpendicular to the rod, since you have that extra space. So I'm guessing these ones in particular are a no-go. However, we do have other ones that have smaller groove width. Here we go. So this is 4.5 right here, and these ones I believe were even smaller than that. Yeah, that's 4mm right there. These are V-groove though, so these ones are V-groove, these ones are U-groove. I'm assuming anything under 5 should work for us. I have not bothered grabbing any CAD models. I'm just going to do a quick model up, and we'll go from there. Otherwise, I believe that's everything I wanted to touch on to get us prepped for this stream. So we'll switch over to Fusione now. Fusione. And let me cue up some more music because I really quick started it late. So add, and there we go. All right, now we have a full playlist. Cue. All right, and off to the races. So again, I'll start with this guy. So this is the regular LM8. I made a copy of it, technically speaking. So we will, actually, it looks like the copy is not open. That looks like the original. I did copy it though. Open-Type, there we go. So we're just going to modify this guy because I couldn't, I actually did look for Open-Type because I was curious how rare the Open-Type LM8s are. And I could not even find a CAD of them is part of the story here. So we'll modify this CAD really quick. And that will be that. And let me pull up on the other screen the 1 second. Edge. Let me get these because we have the technical. Yeah, there's the technical drawing. I was going to say, I'm pretty sure we have technical drawing. So O and U. Let me just move this over to my other screen really quick so I can keep an eye on it. And then we can switch you guys back to Fusion. Where's Fusion? There's Fusion. There we go. All right. So for me, for my technical drawing, the OP. Let's see. Huh. Where is O? Theta. On these dimensions. Huh. Huh. That is weird. I do not actually see. What about E? E would be the opening. I could also use that. Where is E? We might just be winging this then, because on these charts I am not actually seeing theta or E on these charts. I mean, heck, I'll bring you back over here to, at least for 8mm at any rate. So you're back here with me. Here's a theta, but obviously that 15, unless that follows over. Okay, if that 15 is the OD. Okay, I thought this D. Okay, my bad. I can read. It's fine. This D is the OD. So this chart is actually split up and down. I thought these were two separate ones. I thought these were like LM90s, honestly, is what I thought I was reading. Okay, gotcha. Okay. Although theta is still for this first line, which should be our 8, theta is still missing. Everything else says 80, and I still don't see E anywhere, unless you do. Do you see E? I don't see E. I mean, if I had E right here, then obviously I could figure out what that angle is easy, but do not see the E. So let's see if we presume those are 10. So I'm going to guess, because the angle gets smaller as we go down, that the LM8 open type is 80 degrees. Now this is very concerning right now, because A, this was the only place I could find these listed, and B, it's not even on the technical chart here, the open type, which suggests that maybe they don't sell it. So if I hit the add to cart button and tried to buy it, I might run into some issues. So this might be going south very quickly. Again, I wasn't planning on it, but one of those things, might in the future do it for fun, and that doesn't appear like it's going to work. And I just minimized that for you guys. So let's kick you back over to Fusion. And we are just going to go with 80 degrees and hope that that is acceptable. Grab the outside, and hope we can actually eventually get these. This is a solid model. I found out. I went to earlier on. I went to. Let's see, really quick. Let me get a vertical. I went to slice it earlier to look at what bearings were on the inside for the informational stream, and I noticed that it was a click, please. Huh. Fascinating. Okay. I noticed that it was a solid model, unfortunately. So when we slice this, it's just going to be a wall, is what it comes down to. Distance, symmetric, all. There we go. So you can see it just ends up being a wall. I had been hoping that these models were actually detailed with bearings earlier on, because I wanted to know what the bearing size was. They are not, but frankly, it doesn't necessarily matter to me. And there we go. Now we have the open type bearing. And now we'll go ahead and model up really quick the U-groove. Do I want to do it from the front? Yeah, I guess I may as well. And again, this is just going to be a quick sketch. So let us see really quick. Which one do I want to use? The one with the smaller opening or the V-groove one? U-groove one with the smaller opening, V-groove with the smaller opening rather, or the U-groove with the wider one? I guess I will go with the U-groove. Yes, that's what I will do. So let's check the dimensions on this really quick. 4ID, 13OD, 7 across. 4, 13 I said, right, and 7 across. Symmetric overall, 7. And let's see. How do we want to model this? We don't normally do sweeps, so let me do a sweep here. Intersect that guy, body that guy. There we go. There's that. Here is my circle. This is dead center. The depth here. So I guess I will, one of those things, 1.5 ways to skin a cat. I think I'm going to do this and just make this tangent to keep my life simple. The depth on the groove is and it's possible that instead of this being a circle, I need a spline line. I'm about to find that one out. U groove depth 1.7. 1.7. Yeah, because this well, actually I take it back. So this needs to be there, and then we can check the diameter, because that would be the opening. So 3.4 is definitely smaller, so it definitely needs to be a spline line or an ellipse. We have ellipses, right? Yeah. Let's see. Let's do that. We're gonna quinky dink that and make sure you're quinky dink that. Good. And then this opening is 4.5. There we go. Now the funny thing is this is 7, right? Because this, so back to the spline line, this may not be a perfect, perfectly circular. It may not have a constant arc, in other words, because it looks like the edge, I'm looking around trying to see if there's a measurement for that edge right there, and it looks pretty small. It looks like maybe 2 or 3, although frankly it's one of those things, I'm zoomed in pretty far right now, so maybe, I'm guessing 2 is what it is. Alright, that says 1.5. I guess that's about right. Back to zoomed in pretty close here. So it's just playing tricks with how it looks. I guess if I zoom all the way out here, it probably looks more correct. So let us now try to sweep, because again, I do not do sweeps very often. Sweep. I don't think a revolve is going to work, but we can always try revolve next if that doesn't. Sweep. Cool. There we go. Cool. Nice. Sweep worked. I'm kind of curious, so let's try revolve too. The revolve will go around the axis. So yeah, actually revolve should work as well, because I have this axis right here. There we go. Again, 1.5 ways to skin a cat. Actually, that came out with fewer defects on the surface. So if I suppress this really quick, you see how we got these little, or at least that little random defect there, whereas with the other one we don't. So I think I'm going to just stick to the revolve. I was going to do sweep just because, again, we hardly ever use the sweep function, but as it turns out, the revolve one looks better. And that is, so the only question is, do I want to put the little bit of effort in just to separate the bearing from the wheel? I wasn't going to. Let me take a quick look at this picture. I don't have a dimension on the bearing itself, although it does obviously say at the top 620. Actually, this one does not say 624. I think 624 was what the other one says. Okay, there we go. 624 ZZ4. ZZ4, what's the 4 at the end? I'm not actually sure what this 4 at the end is. So 6 is the bearing type, 2 is the load, 4 is the ID, which is correct. ZZ is double shielded, and 4 at the end. Let's see really quick. Time to Google. Bearing nomenclature. Let's see. ZZ, and the fourth one is, or the last one is, radial internal clearance. Except for that says C3, so that doesn't sound correct. Let's see. Radial internal clearance. That's CM there. Huh. I remember seeing a site that I really liked the breakdown on. Let's see. There's ZZ. Okay, no, this one is... Okay, so I guess the C is optional. It's possible that they just left the C out and it's just 4, which is extra loose bearings. Ball bearings. It's possible they just left the C out, and the 624 ZZ C4 would be the more correct way to put it. Regardless, that is a bit of a tangent. And we should probably get back to designing, because for my purposes, I don't particularly need the bearing visible in there. So we will just hang out here. Leave it as is. Oh, actually, I totally didn't notice because the sketch was there. We got a line on here, top here instead. All right, you know what? Fine, if I'm going to end up with a line either way, we'll do the sweep one. Oh, wait, there's a line on 2 sides now. All right, how anal do I feel like being? Just one side? All right, just one side. We'll live with it. All right, and save that as you grew. Let's see. Do these have, what are these referred to as? All right, it doesn't look like they have a code. So, like a special designation. So I guess I will just say for ID 13 OD, I'm going to leave the thickness out. U groove bearing, and that will be fine. And now we can go ahead and start working on the linear slides for both types. So do I have an random 8mm rod just for the heck of it? It's one of those things. An 8mm rod is just a circle, so it's really not necessary. I'm just curious. Rod. I might have one in downloaded assets, but again, it's a little bit silly, a little bit extraneous to bother with. So we are going to go ahead and just start designing. So for the first kind, we will be doing this version just to get it out of the way. Again, given prices and given the fact that they don't even have dimensions for the LM8U Open, and I can't get it anywhere else, this may never actually happen, but at least we'll have a design for it. So let's go ahead and save this so we can insert the LM8UU. Do I want a new... let's see. Question is, do I want a new project for all this kind of stuff? Nah, probably not. I'm probably going to just save this in miscellaneous. Yeah. LM8UU bearing block. We'll just do the bearing block. I'm not going to... we'll just do the bearing block for now, and then I guess I'll do another file just to model out how the rail system is going to look. Because that's the other thing that I have not mentioned, is that we've got a little bit of an issue with the rail system, but it's one of those things that can't be overcome. So let us go ahead and insert into this, keep this open, grab our LM8, insert, okay, and let's see, we're only doing the bearing block in this design, so I'm going to go ahead and not bother creating a subcomponent because it's going to end up being, I believe, just one solid block, so it's not that big of a deal. I'm pretty sure we're just going to do this. The one issue that I saw going into this is how to keep this from rotating. So in theory, this bearing, right, can rotate around inside of this block bearing holder. Now on some designs, I saw some designs and certain sizes, they actually put a plate and rivet the plate to the bearing and to the bearing block. So the bearing block is riveted to the bearing via this plate that they put on it. But that was only on certain sizes from the same company. So the company, it's not like I was seeing different companies do different things. It was a company for specific sizes did that. And on the other sizes, even the larger sizes, I could not tell how they were keeping it from rotating inside of this bearing block. For us, I think my recommendation is going to be to super glue this in here. Super glue or epoxy it. It's one of these deals where I don't particularly like that solution, but at the same time, and I think I'm going to project out this guy right here, and we're going to actually stop the block parallel with that. But at the same time, point being, the alternative is to like do set screws and just put pressure in onto the bearing to try to keep it from, I guess, you know what, if you did a little, if you drilled it into the bearing just a hair, or maybe, you know, enough that you don't damage the races, okay, in a specific spot so you don't damage the races, and then put a small set screw through there, that would be the alternative to it. So that's an option. It's one of those things, it's just plastic at this point, so all you really have to do is drill through the plastic. I don't, you know what, it's one of these things, it's simple enough to add just a simple hole in the side. Maybe I do go ahead and model that in as well. I wasn't going to. The point of this conversation was that I was not going to bother worrying about that. But maybe I'm wrong. Maybe I decide that it is simple enough to do. Now, for this wall, it's one of those things, the whole entire point, as we discussed in the previous video that you should have watched, the whole entire point of this is to be relatively rigid. So I'm thinking thicker walls is what I'm thinking. The next problem, it's not so much a problem. So let's see. Let's see. What kind of bolts do we want to use? So to mount the bolts to, or mount the track to the ground, I saw somebody say that they were using 6mm bolts. But to mount the, I forgot to check what it is to mount. Guide. Let's see. I forgot to check what kind of holes they come with standard to mount to these linear blocks. Let us see. Just really quick hopping on Amazon to check. Holes. Thread. One guy here is saying 8 millimeters, but that sounds massive. So we are going to go for a second opinion really quick. Let's try another product. 45. Thread size, M5s. That sounds more reasonable. Okay. So we can use M5s, and it's one of these deals where I'm thinking we're going to use captured nuts. Although for this, maybe we want to do threaded inserts. So I normally don't use threaded inserts. It's just a matter of, let's see, just because we're doing something kind of fancy right here. That's what all it comes down to in my mind. Is we're doing something fancy. Maybe we just go ahead and do the threaded inserts. I know my threaded inserts tend to be smaller that I have over here. Let me just really quick pull the box and see whether or not I have M5s. Let's see. It looks like I do. That does look like an M5. My box did not actually come with a label card, but this looks M5 to me. Grab some M5 bolts out really quick of the bolt box. There's a loose one, and the answer is no. The answer is that is an M4. It looks awfully big, but I can't get the M5 is not fitting. So that would mean M4. In which case I do not have M5 threaded, threaded inserts. So we are down to the M5 nuts. So I'll pull those out since I have the box open. And let's take a look at the dimensions on those, because again, I don't normally use larger nuts. So grabbing the dimensions, and those would be 7.8 across and 3.85-ish thick. So I'm thinking to put them here and here, like in line with this. I guess let's go ahead and leave this as is, and then I'll make that decision really quick after we get this plotted out so I can see. Whoops, not that one. Two-sided object. And the other thing is, to help this not fall out, I'm thinking of putting a lid on the front. So yeah, I guess we can extrude this here, and then I'll extrude a second one afterwards. I was thinking about whether or not I do an offset right here was the design decision. Probably not necessary, because we can just come back and hit the E button again, pop the sketch back open, bodies, grab everything this time, or not everything, but both of those things rather, from object, there, or actually not there, I take it back, turn the body back on, there, -3, so again, I'm expecting there to be something holding this on the inside to begin with, so the wall thickness on the ends I'm not as worried about, so I'm not going to make it 5 like the other wall thickness. Create feature mirror across midpoint, which is we're building on the origin right now, so we get to use. Sorry, that didn't look like I grabbed the midpoint, but okay, there we go. Let me get this a different color just to have an easier time differentiating it. There we go. And now I want to come up here. Let us make that plane. So this is bearing layout. Again, trying to stay a little bit more organized with my sketches, since we have down pat are staying organized with the planes now. Top of a bearing block. Bearing block. There we go. Now let us look at how these captured nuts line up. So I said, if I recall correctly, 8 point. No, it was, bother. 7.8. Just double checking my calipers really quick. They're 0. Okay, they're reading closer to 7.85 now, so we'll go with 7.85. Also, that line does not look center from this perspective. Huh. Fascinating. So that is, yeah, okay. Things went weird here. We will come back to that. 7.85. Let me just see what this looks like, because we need to come back and determine. Let's see. This needs to be, I guess it could, the capture nuts could come in from either side. So I guess I'll make them parallel to this edge. And then we'll plan to feed them in from this edge. 7.85. And give ourselves, honestly, so the captured nut could actually be collinear. Honestly, I normally give myself some wall thickness. Oh, that's right. No, we need wall thickness on this side, though. I'm still thinking of it going the other direction. We need wall thickness on this side because we're feeding it in from this side. So, the other alternative is to feed it in from the bottom, which is something else this slot, so normally I would toss a slot in here, is where I was going with this next, to feed this in. Just because this is a pain in the butt to get the bolt back out if it strips out or something of the like happens. I have been just defaulting to putting a hole in the bottom and then pulling it all the way through. That's not that big of a deal for this design, so I think I will. However, as previously stated, we do need a wall thickness here to keep this from rotating out, and as we can see, that does go directly through the bearing, which is what I wanted to check here. So we have 3 options. 1, we can make this block wider. Right now this is the minimum width that I'm willing to make this block. We can make it wider though. Option 2, and for the record, sorry, right now, as you can see, we might be able to fit 4 on here, but we don't really need to. Fact of the matter is that this could go dead center. In all reality, this could go dead center because these styles of bearing blocks need to work in tandem to stop them from tipping back and forth. So you generally have 2 sets of rails so that it stays rigid perpendicularly, stays perpendicular to the platform you're mounted to. So we really, frankly, could just get away with 1 if we wanted to, put this dead center of this block, because we're going to have another one over here. Or we could have that, obviously, if we're only using 1 of each of these block bearings per rail. Then we only have 2 connection points to the rail for whatever we're holding. Alternatively, we could have this here and another one up here, again dead center. And then from there, we would have 4 points. The weight would go in, well, I mean, the weight wouldn't necessarily go in theory, but the connection point would be dead center of the block, which is nice. Yeah, you know what, let's go ahead and go with that one. So I'm going to go ahead and put this dead center then, in that case. I've talked myself into it. You will be dead center. And, I actually think, instead of being parallel here now at this point, I think I am going to drop it through the top. So the bolts will have to go in before the bearing is fixed in, and the bearing will then, you won't be able to get the bolts back out after the bearing's placed in if you glue it in. This is a problem. The alternative is to make this wider if we are going to take the bolts out the bottom. Alternatively, we could keep it oriented in this direction and have them slide in. The fact of the matter is that if these guys strip out, This is the argument that it doesn't matter, okay? It's the argument I'm presenting right now. If these guys strip out, in that case, this plastic is absolutely worthless. We need to get the bearing out of the plastic, print out a new plastic piece. So, at the end of the day, it doesn't necessarily matter that these bolts are stuck in here because, the only situation in which it matters is if the nut itself strips out. If the threads on the inside of the nut strip out, then it matters that we can get the nut in and out. Otherwise, if it's the plastic which fails, which is the more likely scenario, in that case, the whole entire plastic piece is broken, so we got to replace it anyway. For that reason, I'm going to go ahead and drop these straight down, suck them in from the inside here, and then put the bearing in afterwards. That is the design decision I am making, and I am going to stick to it. Now, one of these deals, from here to here, right now, we have nearly 2 millimeters. When we put this other one in here, let's go ahead and do that. All right, so back to, I guess, so this gives us more than 2 millimeters actually if I do this, because we are dropping right in through the bottom, so it doesn't matter what our orientation is here. So that now is 2.5 millimeters. Okay, I'm a bit happier about, I take it back. I still haven't technically, I know I'm bouncing all over the place here with my explanation, but, let me do this, delete that, and get this centered on this line segment. So get this perpendicular, get this midpointed, and then get this guy midpointed to that. Alright, now we have an actual distance here, which is 2.8 something, so nearly 3 millimeters, so I'm happy with that. Okay, cool. And then we can go ahead and make this a 6 millimeter hole, or a 5 millimeter hole, sorry, we're M5s. There we go, and these circles are no longer important. Let's see, right now it is saying I am not confined because, you did not actually get centered. Okay, and you are also not centered. Okay, there we go, and I will just go ahead and do this one. I had this other guy in here just in case I needed to get the distance between these guys, but the distance is going to be fine at this point. Now, let us double check our centering here because something seems to be wrong before we do these extrusions. So, here is this. Here is my origin. That looks centered. Let us really quick take and inspect just to make sure. That is, that is the wrong plane. This is the farthest stop point right here. Okay. Well, it doesn't necessarily matter. I could do any point so long as I'm consistent. 12 millimeters, and I think these are 24 millimeters wide, so that would be accurate. Okay, yeah, so this is centered. That is good. So what happened here with my extrusion to make me off center? That appears to be centered. That looks accurate. Okay. And that mirror does not look accurate. Okay, the preview was accurate. The mirror was not actually accurate. As always, well, not as always. Since the changes happened, Optimize still does not work, unfortunately. It's funny because I think I've said this before in another stream, but it almost feels like they actually swapped Optimize and Adjust, and Optimize is now no longer, they're backwards now, rather, is what I should be trying to say. So it is Optimize that works, and Adjust that doesn't, because Adjust is doing what Optimize used to do, at least that's what it feels like. So make this parallel again. And now we're good to extrude because everything will be centered. So distance all, flipperoonie, get rid of the LM8 to make sure we don't accidentally kill it. extrude. This is captured nut, mounting hole and captured nut. And actually, let's come back here to the bearing layout, because now we know that our nut, and I'm going to go ahead and put this block in here as a representation of our nut. And I'll go ahead and make that. Don't tell me I'm going to get this. 7.8. I think it was 7.8. I'll find out. And this was 3.85. Oh, that's right. This was 7.8, I believe, the first time I measured it, but it came out to 7.85 the second time. Anyway, point being is now I can go ahead and toss. Yeah, never mind. I did this backwards. That is the nut at the top. We want try to get a hold of that line. Please, can I have the line? Thank you. Uh-oh. I connected it. There we go. There we go. You should be centered over here, rather, is what I wanted, because this is where the nut's going to be. And then we're going to have this 3 millimeters of wall above it. There we go. That's what I wanted to fix. And now we can go ahead and extrude this out. Offset -3 millimeters. And distance all, actually, because again, we are going to just countersink that all in. Flip that around. There we go. The bearing is still off, so we're good. And hit OK. Now, what is unconstrained over here is my last question. I do not see anything unconstrained, but it says that my sketch is unconstrained. And I am very particular about that. So let's start dragging stuff and see if we can't make anything move. Doesn't appear that we can, so I guess I just got to give up and cry about it. Okie dookies. So back to mirroring these features, those two. Okay. And for right now, I think I'm going to keep everything tight. Maybe not this. We can probably open this up just fine without causing any problems. And I'll do a full millimeter just because it doesn't matter. And actually modify this one. Features that. Okay. There we go. And turn the 8 millimeter bearing, block bearing back on. There we go. And we should be good. Oh, that's right. I was going to add. I take it back. I was going to add the set screw in the side. Okie dokies. And I guess I may as well do it on both sides. Let's see. From the front, this is the left-hand side, right? Yep. So left side of block bearing. Yeah. Bearing block, rather. Outside. There we go. And our sketch. It's one of those things, if I do one on each side, then we're probably good with just one hole. And I'm going to make an M3. Again, normally I would go ahead and keep all the bolts the same, but because we're worried that this one is going to, let's see, I guess I'll use, how do we want to do this? Okay, I guess I will take the center point of the overall bearing. Because we're worried that we're going to run into some races anyway, the bearings or their tracks on the inside, I'm just going to make it a smaller bolt, an M3, and we'll go from there. Distance all, flip, and yeah, actually I don't have to mirror it if I do that, right? So Not that one. I wanted to turn that one off. There we go. And this is the bearing set screw. Now, right now, the way we have this set up, back to captured nuts and threaded whatever, the wall thickness right here is only 5 millimeters. Let me double check that I have that right. Yep, 5 millimeters. Going into the side of that, looking at my box here, I think this one is a 3 millimeter, or is this 2.5? Let's grab a 3 millimeter bolt really quick. Where's my 3 millimeter box? 3 millimeters? Yep, 3 millimeters. Alright, let me just check that this is a 3 millimeter. Actually, no, it does not look like it's 3 millimeter. Looks like it is a 2.5 just from the looks of it, but let me not double guess myself and actually physically check. Okay, yeah, that's a 2.5 then. So that's a 2.5, which will make this one a 3. Point of what I'm doing right now, I'm checking what the smallest threaded insert is I have. Okay, that's a 3, and this does look like the smallest threaded insert I have. We have 5 millimeters wall thickness to work with, and this one is 3 millimeters. So that seems good enough to me. Honestly, because it's a threaded insert, I probably could go the full 5 millimeters. I'm just a little concerned about running into the wall. So, in theory, if we wanted to, actually, sorry, that was the other thing I was going to do while I had this out, is measure the inside, not the inside, but the smaller portion, the lesser diameter, I guess I'll call it, of the threaded insert, and that's 3.8. So in theory, we could make this hole 3.8 and plan to use a threaded insert. I am not going to do that simply because the alternative, as we discussed, was to actually drill a hole in the side of the bearing, or at the very least a small indent. Well, actually, if we did a small indent, then you'd want the you'd want the threaded insert because you need something to hold the bolt in there. But you know what? Actually, here is an idea. The point being is that if you drilled a hole in the side of the block bearing, inside of the LM8 rather, not the block bearing, inside of the LM8, in that case, you could just get away with just the M3 bolt, in theory, I believe, because it would probably bite into that hole, especially depending on how exactly you drilled that hole and whether or not, in theory, you attempted to thread it as well. There's a lot of unknowns here. New component. My brain not work. There we go. LM8UU OP bearing block with threaded insert hole. So I'll go ahead and do this really quick. We said 3.8 was the hole size. Whoops, Control Z. Project. Okay, that was the wrong body it projected, so let me make sure that body's turned off. There we go. And we'll make this 3.8 for the minor diameter of the threaded insert. And distance all. There we go. So now we have two options here. This one will get a threaded insert, the other one won't. At least on these sides here. And that is that. So now that we have this done, so it's funny because we are already 50 minutes in, surprisingly enough. I swear this stuff takes longer than I think it does. But I wanted to just mock up how this would work. So we'd have an 8mm rod here. And I'll go ahead and extrude that symmetric, new component, and let's make this 100 for right now for demonstration purposes. 8mm rod. And let's hop in here. And here is the rub. How do I demonstrate this? I guess from the side. I guess I will do it from the side. So, here is something I realized as we were talking about this. As I mentioned, or not as I was talking about this, as I was investigating further. As I mentioned, what I found online was that they said that this, let's see, I probably should have drawn this a little bit differently. So this is going to have some extra lines that were not necessary, but that's besides the point. There, tangent there, and point being, this is 6mm right here. Okay, so if we look at this line right here, which is where the bolt comes through, as you can see, that is massive in terms of the rod itself. And furthermore, if we draw the bolt head into here, so let's say that that is just where the bolt comes out and the bolt head is flush with that. The 6mm bolt head, I believe, was close to 10mm. Let's see. The other one I think I just said was 7.8. So, alright, I'm going to call it 10mm for the purposes of this conversation. I don't know where I got 10mm, but for some reason that's the number. Oh, that was a button head. I think the button head came up as 10mm. Point being is that if we bolt this down, this rod down into the ground, with this 6mm, first off, you can see that there is not much rod left on the outside to begin with, which is a little bit of a problem, you know, if the rod's basically falling apart at this point. The second thing is, if we have the bolt head on top, the bolt head is actually larger diameter than the rod itself, which is another problem. Now, this is speaking specifically about 6mm, so if we change this to 5mm, and we just saw that this, okay, so yeah, this the 7.8 was the nut. So let me check what the button head is here on the 5mm. Button head is 9, so the button head still doesn't help us much. However, as you can see, we get a little bit more meat here. And one of those things, if we went to 4 or 3, obviously this would start looking better and better. However, point that I'm getting to right here is, at this point, it is not really feasible for us to bolt downwards into whatever we're attaching to, which is how you normally use the linear rails. In our case, we're almost better off. Let me hit Control-Z a whole bunch, because I want to undo those constraints. There we go. We're almost better off, I think, doing this instead and having the bolt head down here on the opposite side of what we're bolting into. Now, this does mean that we've got a blind hole. I think it's called a blind hole. Regardless, this bottoms out here for a bolt, so we need to have bolts of a specific size. In this case, this is an 8mm rod, right? So we can only get maximum 4mm here, probably only 3 just to be safe, maybe 3.5 to be safe. And then whatever we use for standoffs, and this bolt more or less needs to be exactly this length, short of stacking washers. Let me pull this out a little bit just to demonstrate. Attempt to pull this out a little bit. There we go. I'll just grab that guy. Short of stacking washers, you know, behind it, which is always an option. You can always stack washers. So it becomes a little bit more complicated than normal linear rails, is my point. The other alternative, which is I'm a little skeptical of, is to weld the rods onto the bottom of this rod. Rods, sticks, whatever the heck you want. You know, just weld pieces of metal down and then attach, you know, a plate to the bottom and attach the plate to the base. That's another option. So these rods are basically all chrome plated as far as I've seen. You're not supposed to weld chrome. It's bad for you. So I did do a quick Google search and people said, well, grind the chrome off and then weld the steel underneath the chrome. We're already past the point of being a maker not at being a maker, but the type of content we do over here. Yes, obviously I've demonstrated that I can do a limited amount of welding, but this seems less feasible. I'd sooner do this blind hole here, again, whatever you technically call it, and just thread that in there and hope we don't bottom out. So that's where we're at on the design here. Unfortunately, it does not seem feasible to me to bolt through the top because we cannot countersink the bolt head is the biggest problem. If we could countersink the bolt head, then I'd do it. However, there's just plain not enough meat up here to do that on an 8mm rod. So we're going to have to come from the backside and go from there. Okay, cool. So that is that discussion out of the way. Let me go ahead and, again, we're just going to mock this up really quick. I'm still in a sketch. There we go. Tangent off the bottom, reference plane, origin. There we go, and 180. Bottom of rod. Project. Turn the body off. Magical fusion double line. What does it mean? Again, I'm going to drop down to 5mm here, just because 6mm takes up way too much of the diameter of the rod. And sorry. Let's see. Distance from the end here. I think I am going to do. Let's do 5mm. And now I'm going to go ahead and we will. I was going to do the hole first, but maybe I should. Yeah, you know what? This probably should have been in another object, but I'll cry about it. Again, this was in theory just for demonstration purposes. This rod is on center line, right? All right, good. Two-sided. Distance to object there. And then other distance is, let's say, 10mm. And these are backwards. So, distance 10mm and distance to object. Whoops. Wrong object. There we go. And new component. I'm going to just join this later. Actually, this would be the bolt that I've got right here. So, yeah. I'll just call it the bolt. That's fine. New component, standoff. Come in here. Come in here. Project out this guy. Toss a wall thickness in there. Just like 3 is fine. And then extrude this down. Distance to object. There. And now we can go ahead and pattern those down the line. Pattern. Whoops, that is not pattern. Pattern. Components. Actually, you know what? Maybe I want to just do bodies. Just because I don't particularly want to make a whole bunch of components. That and... Whoops. That and... Oh, you're gonna really do this to me? Alright. I give up. This is just for demonstration purposes. Huh. Okay. You're not gonna give me that, huh? Let's find a sketch then. Oh, I never... There's a sketch. Never named that sketch. My bad. And let's go every 20 millimeters. Bother. You're being difficult. Alright, well. Let's see, I can't use one to flip it around. And it doesn't let me use the whatchamacallit for the path. This is the bolt. I guess I will come in here, project this. Actually, let's intersect this. I take it back. Let's intersect, because that will give me a line. Turn all these off as ever one. Hopefully that should work. And now, pattern, path, bodies. Yeah. I really don't want the extra components, honestly, so let's try this now. Spacing. I really wish you would. 0. 5 is fine. And rod line. Just do the same thing on the other one. There we go. Select my line. Spacing. I don't know why it defaults to extent. Nobody uses extent. It's a waste of time. You can't even use toObject with extent. If you could use toObject with extent, then it would be more useful, but you can't, unfortunately. So it is a waste of time. Chrome. Try that again. There we go. Turn this off, this sketch off. Huh, that's... There we go. It's looking pretty ugly, honestly. Whichever. Red. Plastico. Standoffs. There we go. Let us combine that with that. Putting more effort into this than I probably should have for a demonstration. Keep tools. And now save so that we can insert LM8UU slide guide. Now we can insert this one into here. That one into here. There we go. And that is fine with me. So looking at it, it looks like our wall thickness is going to have to, because everything's on origin, it all lines up automatically. So it looks like our standoffs are going to have to probably be cone shaped would be the best, just so that we can still have a wider base. Alternatively, we could always cut them down into D shapes. The standoffs actually are not 100% necessary. So the alternative actually is to put nuts down here. So you throw nuts down here, weld them onto your platform or countersink them or whatever have you, and then thread the bolts through onto the rod. And when the bolts bottom out, yeah, I guess that's the way to do it. So it's threading. It's a little bit difficult, frankly, but it should work in theory. In theory, so long as you have everything exactly sized correctly. You thread the bolt through the nut, which is stationary on your platform that you're connecting to. And at a point, so long as the rod is... nah, it's not great. It's not a great solution. I'm going to stop talking. It's probably better just to modify these standoffs so that they're not interfering with the LM8 open version right here. Simplest, quickest solution. Yep, okay. So that is that. That is our first slide bearing. And we have been going for 1 hour and 5 minutes, which is a little bit annoying because this was supposed to be a quick, stupid, done build. There's that. So, boink, boink, and boink. Let us go ahead and get this next one built. So on this next one, we're going to need an eccentric nut. Let's save it really quick. Boop, 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 boop. U groove inner guide slide guide, whatever, block. I don't know. I don't know how exactly to describe this. So that is the name it's ended up with. So we are going to go ahead and this one, because this one wasn't intended to be quick, I'll go ahead and do this a little bit more professionally. 5mm rod, come in here, make our sketch. 5mm. Actually, I take that back. Let me do horizontal. Rod. 5mm. And our spacing here. So the funny thing is, actually, hilarious, funny, ha 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 ha. So we're going to have a theoretical bearing right here that the OD is 13mm. In theory, I should be drawing this, technically speaking, like this. 13mm. That is centered here. And it is going to have let's see, where'd my lips go? There it is. So this was 1.5, I think, 1.5, and four point 4.5. All right, let's double check. 4.5 and 1.7. I knew there was a number that was not 5 in here somewhere, I could not remember where. There we go. I guess this was the only dimension I was worried about, so I didn't need the full arc here. This is the only one that I wanted to delete this and come in like this. So in theory, that is how this is writing. In theory, this is 7mm right here, and this is all, frankly, sketches. So in theory, this is the placement of it. Now, my experience, obviously, doing multiple of those V-groove roller plates, is that you don't bother compensating for the eccentric nut. So I am going to leave this here. In theory, this rod can be slightly out a little bit more because of the eccentric nut. But again, the experience I've had so far has been just leave it alone. Just make it. Don't bother. So we are going to just put it there. So the deal here is that we are going to have, in theory, we were going to have plates that held these rods like this. And yeah, I guess that holds it far enough. The only place I was going with this conversation was back to this opening here. As you can see, that moves this further in and gets us closer up here. But if I make that all 5, you know, at this point, this plate, or this bracket rather, that's holding this rod is not really holding it terribly well. The one counter argument that I'd have here that makes it not that big of a deal is the same exact one that we did over here on this linear rail, which is, okay, we can drill the back. We can drill and tap in the back and bolt the rod to the bracket. That is an option. So back to the fact that we have an option for a 5mm opening. What you call it? A 5mm. Oh, actually, here's the other thing. You see how this U is actually outside of here? So let me back up a little bit. So there. So if we had something that was like 4.7, that may be better because now the inside of the bearing is just about touching. But my point being is that if we ever get to the point where the rod is too far out of this block, the only thing I was getting there is that we can always just drill and tap, or, well, yeah, it would be drill and tap. Yeah, because there's no way we're going to get a nut or a bolt head on the inside here. So drill and tap the back of the rod here for, you know, an M3, M2, something like that, and bolt it to the block. However, I'm hoping to avoid that. Long story short, there we go. So that is where we're at right now. That's the spacing on the rod, so we can finish this. And again, I'm just going to do 100mm as our test project here. Actually, Okay, I just did all this right, and it occurs to me that I was only going to do the block in this one like we did over here. So I was going to do the block and then the slide guide separately. So yeah, about that. Let's pretend that never happened. There we go. And let's just come over here and insert this into here. I will insert the M5 nut, eccentric nut, insert. Oh, actually, this M5 eccentric nut does not work. We're going to need an M4 eccentric nut because we have 4ID. Let us see then. Let me open up another tab over here. Amazonia. M4 eccentric nut, huh? Do those exist? Those are T-nuts. Those are T-nuts. Okay, you type in eccentric nut and you get a bunch of T-nuts, as it turns out. So, we will be printing a M4 eccentric nut, it looks like. Fascinating. So, yeah, that is an slight issue with the design, but not something we can't overcome. So, let us go ahead and design that first then. So, hop in here. Here is our ID, which is 4 millimeters. I should not make that concentric though, because we are not concentric, we are eccentric. And I want a millimeter of eccentricity. There we go. And then it's a question of what wall thickness do I want here. I guess we'll try to do it with 1. It's one of those things, everything's so small here. I'm kind of curious what I ended up with last time when I 3D printed my own eccentric nut. What wall thickness I ended up on that one. This tangent to that. Can I be tangent to that? That's a good question. Alright, I can. Good. So we can up this wall thickness if we need to. Honestly, it probably should be like 2. And now it's tangent out the other side. Good old fusion. Alright, there we go. Tangent there. Okie dokies. So there is our top of our eccentric nut. And I'll just go 3 millimeters. And now, from the bottom of eccentric nut, bottom of, or I guess I'm going to call this top of hex, because that's easier to understand. So we're going to put the hex on here. And project out this guy. Okay. And that is on center. Is that really on center? Okay, it is. Okay, good, good, good. One of these things, because everything's off, it makes things a little sketchy to look at. So here is our hex. And let's see what an M4 nut hex normally looks like. M4. M4 is 6.8. Let's see, 6.8. Alright, that is a lot smaller than what we ended up with. Let me grab the M5 eccentric nuts. Alright, let's see what proportions we're looking at as our baseline. Let's see. Come on, bag. Actually, why the heck did I get this bag? Derp, we have one right here. This is the one that I drew though, right? So how did I do this? I did a 0.8 here. Okay, I probably took these dimensions honestly off of... Huh, that's weird. I did cross... Oh, I might have gotten these dimensions off the internet. I probably got these dimensions off the internet because I normally don't do cross points like this. I do normally do cross flats. So, let's see here. So this is the first issue here, right? Is that this circle right here, if I make this circle tangent to that, this gives me a wall thickness of 0.2. And that's probably alright in metal. That is not terribly alright in plastic. So that's effectively a 0 wall thickness. So to be fair, let's see. Let me go up to Control Z. Let us see what the 1mm looks like. Oh wow, yeah, that's way off. So if I tried to print this, do I have... so it would have been here. I'm trying to think of where I put my original... Let's see. I wonder where... No, that's not the actual plasma cutter that I'm thinking of. My 3D printed eccentric nut. I'm curious where I designed that at. Let's see. So I do not see the original one, which means that the original one is probably just designed inside of whatever project it was in, which means that I'm probably never going to find it. At least not anytime soon. So let me see what this distance was. This was 9.5, and a normal M5 nut is 7. So the nut part ended up a good 2mm wider as a proportion. Yeah, I mean, this is a little bit. Well, we can. Let's see, finish. Well, two things. One, let's go ahead and up this then, in that case, to 9. And I'll call that my highest point. Do I have a 9mm wrench? I don't think I do. No, I have 10. Huh. That is fascinating. That is fascinating because I'm pretty sure this is the wrench that... Yeah. Okay, so the M5 nuts are 10 across flats. What did I just say here? Oh, I said 9.8 is what I said here. Or 9.5, okay. Gotcha. So it's basically 10, which is why I can use the 10mm wrench. I'm thinking since we're 3D printing this anyway, let's go ahead and just make this 10 because I have a 10mm wrench. Okay. So we're going to make this 10. And then we need to come down here and figure out what the heck we're doing with this. So the other one was... The other eccentric nut was smaller. So let's see where we're at now in terms of bodies. Okay, so that is acceptable then in that case. Okay, that's fine. That is fine. Okie dokies. And the last thing to do is just to constrain this. It's one of those things, there's nothing relative to the nut that really matters. So, actually, I take that back. Let us Control Z. Let me make sure that I have that hole going all the way through. And now, let us go ahead and we can go ahead and check what the thickness on this guy is. Actually, it should be like 8mm, right? If I recall correctly, it is 8mm. All right, cool. I think we will just go with 8mm spacers then. We'll just stick with that for the time being. So that is that. Now, do I want to cheat a little bit here? The idea here is that if my printer... So let me do this really quick so that I can visually explain. Go down to 1 here. If my printer does not print yay much of the wall, it really does not matter. There's enough wall left over that can be held by the hole that can be, you know, stick inside the hole that it's going to be embedded in. So it's actually not that big of a deal. So I guess I will do that. So I guess we will go down to a minimum of 1 millimeter. Obviously, we had extra space because of this guy right here. Okay, only other thing I'm playing with in my head right now. Nah, it doesn't make a difference. I was going to say, if we could get this outside actually to be the same diameter as the 5 millimeter, in theory that would make these interchangeable. It's just a matter of the ID being different. But there's no real reason, I don't think, to do that. So I'm going to leave it as is. So that is our eccentric nut then. And for eccentric nut. Eccentric nut. There we go. And we can go ahead and insert that into here. Hop back. Miscellaneous. Miscellaneous. And for eccentric nut. Insert. Okay. So there is that. And we want 3 of these guys. As soon as I remember where I put them. Let's see. I called them 8 or 4. There we go. Insert. I guess I'll turn you sideways for now. Okay. Insert. And I'm inserting them individually just in case something happens. One of those things, again, when Fusion links copies, it sometimes can get really annoying. So I'm just going to avoid that altogether. Alright, so that is that stuff. And then I just need a 4x8 millimeter spacer. I guess we just go ahead and, since we're using components, we'll make that another component in and of itself. Oops, Control Z. 4 and 3 millimeter wall. Sounds fine to me. That will get us to a 7 millimeter overall, or wait. 3 and 3 is 6. And 4 is 10. So actually we want that. Oh no, that's fine because our rollers are 13 overall. So we can afford 10 overall in that case. And this is 8 millimeters. Oops, Control Z. And I probably should also do this. And save that. 4x8. M4x8 spacer. There we go. And back over to the design. Come down here. Insert and insert. You are in the correct orientation. Thank you. Insert. Okay. And now we have all our components. So now we can just build the block. Yep. Let me let's see. I'm kind of curious. I don't recall off the top of my head. Just doing a quick search really quick. Quick search quick. Yeah, okay. I was just checking because it's one of those things. I was kind of curious whether I needed to, and I guess we won't for now. But in theory, this is going to end up just being a flat box on top with 3 holes in it. Like, that's how simple this design is. So let's see. I guess I won't do that. I guess I will turn some of this stuff off. What did I miss? 8mm spacer. There we go. I'm going to project out that guy. Make him a... make his OD at any rate. A whatchamacallit. A construction line. We'll center up on that. As soon as I figure out how to click, because evidently my hands do not work. And then, in theory, this is a 5mm rod. Again, actually, I kind of want... Okay, so remember when I deleted that rod? Probably not intelligent of me. Just saying, probably not intelligent. Also, the other thing that's not intelligent of me is... Control Z. Back to what I said, we'd start, for this one, we'd go ahead and include the, do it directly on the component, rather. So new body. Let's see. All right, yeah, I'm gonna want the rail in there just so I have an idea of how wide to make the body. So I guess we're going back to this. Rails. Project out. Well, on the bright side, we do have this here now, so I can use that as a reference. So it wasn't a complete waste of time. I don't have to add drawings. And actually, there and there is how I should put this. And this is a 5mm. 5mm. And that is my spacing then in that case. So I can go ahead and extrude that 100 as we talked about before and did before. Symmetric, both sides, overall. Okay. And then create a mirror. $5mm rail, 5mm rail, and now I'm calling them rails instead of rods. It's okay. Actually, so that makes more sense as a rail, like the component itself, but this I really should call rod. So I'll leave the component as rails because, you know, it's the thing is riding on rails. I get that, but this is definitely a rod. And as we just mentioned, we will bodies. There we go. And now I come back up here, create not a new drawing, new component. And this is the block bearing block. There we go. And I guess where do we put this? So Control Z, not Control Z. I will just come up here first. Let's get some of this organized. Not these guys, but these two. So modify. Where's modify? Align. That on top of that. Okay. And now what I need is, and it's because one of these things, because this is an inserted object right here, the spacer, the eccentric nut. I will go ahead and put this in the top level then, in that case. Top of eccentric nut. And before I do anything else, let me go ahead and make these rigid. Actually, just rigid joint. Just to hopefully make sure they don't move. Or if they do move, they move at the same time. Now I can project everything out. That, okay. And Let us see. Anything I really need to think about? I don't think so. Yeah, I really don't think that we need to think too hard about this one. I'm pretty sure everything's straightforward at this point. Oh, I take it back. We have to be at least a little intelligent and actually go into the bearing block. There we go. That is the extent we have to think about this. It's just making sure that we're creating this in the correct area. And I guess I also should take that guy just as a reference, just so that we can see it, and then we'll turn everything else off. And then I toss this in here, toss this in here as a reference, toss this centered on that, centered on that, and then we've got, let's say, a 4mm overhang here. And then for length, it's going to depend on these wheels here. So these are mock wheels. They are going to be equal to that wheel right there. There we go. And then we just need everything to stay in line and parallel. That looks like I gave it... Did I? Huh. Oh, okay, it got perpendicular to this is what it did. I actually want this to be parallel to the rod, is how I want to define that. And then rather centered on that guy. And then it's a matter of the spacing between the wheels. So let me toss a random spacing circle in here. And let's say 4 is fine. And we can make that tangent to that. And there we go. Now we can determine where we want this in relation to all that. So we have... this is going to be equal to... This is the hole in the center of that wheel. It's going to be equal to that hole in the center of that wheel because they're all the same wheels. And that is just for... actually, I guess that's not for reference. I guess I should bring these holes all the way through. These holes probably should be all the way through to the other side. However, the minimum size we want is probably something like 3mm right here. 3mm. So this is in theory the minimum size. And then we can do anything longer than that for the block length. So now it's just a matter of making that decision. Do 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 do. I think I am also going to make this solid. I was considering cutting that out later, but we can run it all the way through. It's not that big of a deal. Actually, I guess this is a little bit of a deal. Yeah, we probably don't want to run it all the way through. Just because, let's see, an M4 bolt head. I've got socket heads here. I'll just take the socket head size. Socket head size is 6.8, and this guy is 7.6. So yeah, we don't want to run that all the way through because that will be smaller than the bolt head. Or the bolt head will be smaller than that, rather. And have I stalled enough yet? I guess I'll go to this 4. That way you don't see the wheels. If we made this smaller than this whole this right here, then you see the wheels. This will have it overhang the wheels a little bit, so you don't really see them. So I guess that's what we'll do. And the last thing I'm thinking about here is actually I'm not too sure how they're running this eccentric nut. So I can see the eccentric nut adjustment on the top, which is interesting. Huh, okay. Does that work? I guess that works, question mark? Huh. Let me hop you back over to, yeah, because I'm doing fusion right now, you're going to see that. So let's just switch off. Half a second. Boom, boom, boom. I'm going to close that just to get a full screen back really quick. And hop over here. Swap this out to the other screen. There we go. And push live. There we go. All right, so now you're looking at this thing with me. So here's their adjustment for the eccentric. As you can see, clearly that's eccentric from the center of the hole. It's closer to this adjustment pin than that one. I'm trying to visualize how that looks in relation to this U groove roller right here. I think it's just a retained disc that then pivots like this, pivots the thing like this. I think that's all it is, but I'm not 100% sure. The other thing is that it looks like they have it slightly offset to begin with. One of those things where, again, I think we just trust, at least on this initial design, the CAD. Yeah, there's no real pictures, no other pictures that are close up. Go away. Let's come down here and see just the block bearing. Actually, this is a different one, it looks like. Again, off center. And that disc just does seem to... Yeah, if that disc... So that disc thing is off center. I think that works. So one of these deals, the reason I'm bringing this up right now is because you see how you don't see the spacers in here? And you can't get to the eccentric nut from the side because it's enclosed in the rail. I guess I gotta go back now to the other one. So because it's enclosed in the rail, you can't get to the eccentric nut from the side to adjust it, which is my biggest issue right now with the design I'm doing right now on here. For that reason, I'm thinking of going taking that hex nut, that hex eccentric nut out, and replacing it with a disc like this guy. Another somewhat of an issue. I was going to go my normal route of using lock nuts on the bottom. We can do that. We are going to be higher profile because you see how these are just flat screws here. That means that our channel needs to be lower at that point in order to accommodate the lock nut. Okay, you know what? I think that is where we're going with this. So let's hop back over to Fusione. In which case, I'm going to have to take the hex nut back out, which is going to break things. Things are about to be broken. Huh, I'm not terribly happy about this, but it's where we're at in life. Let's see. Yeah, I mean, I can't really think of any better way of doing this. So let me go ahead and we're just taking, my biggest problem is that we're taking up so much space, like relatively speaking, looking back over here, right? We're going to be so high up. It's not funny. So yeah, we were trying to save a little bit of space is what I was trying to do. So we will go ahead and change up the design a little bit. So this is going to be my eccentric disc now. We're going to design it the same exact way we did before. This is going to be a millimeter. This is my M4 hole. Let's see. Boop, 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 boo. I'm just trying to think whether or not there's any other. Yeah, sorry to go silent here, but I am not sure. Back to, this is the first time I've done this and I haven't seen a real life example of it, so I'm a little bit concerned that I do not understand this well enough and this is not going to work, but I guess here we go. I guess I also should determine, let's just do this perpendicular to that. That is the magical fusion double line. Thank you, Fusion, for your magical double lines. Center this on there. These are going to be our adjustments, and this is going to be perpendicular to that. So these are our adjustment pins, and we're going to have to make something similar to a what do you call it, a grinder disc thingy, mabob, wrench, whatever you call that thing. We're going to have to design something like that. I guess I will go ahead with, I mean, I kind of want to do like 3, honestly, but obviously, as you can see, that's huge. I really don't want to use small things, but I don't really have much of a choice. So let's go 2, I guess. I don't want to weld this together. I kind of want to just bolt it together. The wrench I'm talking about, the wrench for adjustment, I kind of want to just bolt together. The wheel is 13. The wheel, so we have the 13 to work with, right? So I'm just going to go ahead and make this 13, point being. And then I guess the way I do this is just give myself a wall this thickness here. Yeah, so we don't have much to work with in that case. I guess I just make it tangent to the top and say that's where we're at. Obviously, the distance between this hole right here and that guy is not great, but I want to be torquing it around center line as opposed to, you know, moving off to the side here to get myself further away from this. So again, that's just going to basically be where we're at for the time being until this fails. So this is, I guess I'm just going to make it 3 millimeters thick and prage that it works. Alternatives is to change the design of this to use something else other than a grinder style wrench. but I don't think I'm going to mess with that right now. There we go. Let's see. This is eccentric M4 eccentric disc. That is all that. Hit the save button, hit the paste button, hit the save button, and now come back here and start crying. Here is my eccentric nut. There's my eccentric nut. Go back, go forwards, go to eccentric disc, insert. Okay. Go forwards, and we also do not need these spacers now. We're going to want to make a different spacer. Actually, I guess we don't even need the spacers, probably. Yeah, we probably don't. Well, we probably want a little bit of a spacer. We'll look at that in a second. I'm going to delete these ones for now, though. That would be these two. Get them off the timeline. Come back here. And we'll do that align again. And actually, this is going to want to be up a little bit. I'm going to give myself 3 millimeters of space here. So let's go ahead and move this component. There we go. And move up 3 millimeters of wall. And then we'll capture position. So there is that. This. Okay. What was this called? Was this top of eccentric nut? Yeah, okay. It's top of eccentric nut, so we'll just do top of eccentric disc now. Please let me edit. Thank y'all. Disc. There we go. And now we got to come in here and re-project some stuff. So manage loss projections. I am going to you know what, let's see what happens if I just do this. How much everything breaks. Does not appear to have broken. So let us see. I think what has to happen here in order for this to work correctly why are you yeah, you are 2 millimeters now. Oh, you got linked to this guy instead, huh? Interesting decision, Fusion. Interesting decision. I don't know how you came to that decision, but you did. Honestly, that should have been linked to the bearing instead. So, partially my fault. Partially Fusion being a little bit silly in my opinion, but I guess this is where we're at now. Okay, so this will be extruded distance to object down to here, and then I guess what I should do is cop in here and toss a 0.5 on here. It's going to be an extra 1 millimeter overall, and on the bottom side extrude without that so that it has space to pivot is the idea here. Sketch, there we go. So there, we don't need that guy. Yeah, we don't need that guy or that guy or that guy. And we do want that hole there. Okay. So distance -3 from object there. And I probably should have put that up again, back to spacers between the wheels and this block. I probably should have accounted for those. So let us go ahead and let's see. Honestly, maybe I just use a washer. Nylon washer would obviously or presumably be better, but it's one of those things. It's going on the perimeter of the bearing on the inside of the wheel, so it shouldn't really matter. Let's see. Where is my M4 washers? There they are. I'm pretty sure these are 0.5 millimeter thickness washers. I'm just going to double check really quick. Let's see. All right, calipers, I actually think they're fat. Calipers think they need to go on a diet. Calipers are saying they're more like 0.8 of a millimeter. So we'll just compensate for that. Let us hit the finish button really quick. We already have the finish button. This guy, move. That guy up 0.8. Okay. Finished now. And let us go ahead and make some. Actually, you know what? Let me pull that washer back out. I'll just model it up really quick since we're modeling everything else up. Grab him again. I also have these. Yeah, all right. It shouldn't matter. I was going to say, I also have these spring washers in here that I never use. But because I plan on using lock nuts on the bottom, there's no sense in having a spring washer and a lock nut. So I was kind of curious. And yeah, I'm getting 0.9 now. So it's one of those things. Back to they're just washers. So I'm assuming they just end up being whatever. There's a good bit of variance between them. Yeah, I'm getting 0.9 on this one. And double checking what I got for the OD here. Yeah, it's still 8.75. So let's go ahead and model this up really quick. 8.75. Remember 8.75. There is 4 millimeters, 8.75, 4 millimeters, and 0.9. Okie dokies. M4 washer. That is M4. There we go. That is a period. Good bunch of men. And save. There we go. And insert. We can close this out, close that out, close that out, close that out, and hop back over here. There's our M4 washer. I'm going to come back here, insert. Okay. And I'm actually going to, instead of, I know I put that move in there, but, oh. Let's get 2 more of those because we need 2 more for the other guys. Insert. Okay. There we go. Okay. Anyway, as I was saying, I'm actually going to align that after I get the washer in here. So, align. Turn these guys off. Turn that guy off. Turn that guy off just so I can get to the washer. Let's do that. That and that. Okay. Capture position. And now come back over here. One of those things again, I wish Fusion remembered what the heck you were doing. Unfortunately, it doesn't. So that's where we're at. Yeah, I guess I'm just right. Just take the face. Just take the face. To there. Okay, and move up the 3mm wall thickness. Finish. So that is down to there. That is down to there. Now I should have the washer right here. The washer does appear to be flush right there. That is good. And then we have the wheel. Cool. Groovy. All right, now we can go back to, I guess, lining the other guys up. Align. Let's get the washer first. Turn this guy off, turn that guy off. So next washer gets aligned on here. Okay. And then align second wheel. Center of that second wheel onto the center of the washer. Turn the wheel back on just so that we can visually confirm. Hit OK. So both of those are in the same align function, which is nice. And then that washer, center that washer to the hole. All gravy. Do do do. Do 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 do. Okay, capture position, turn everything back on. There is that. Again, this is a little bit odd here, right? So let me just look at this without the, well, I guess it doesn't matter if that is in there. Okay, turn the washer off maybe. So in theory, yeah, this doesn't really line up. Again, I'm a little bit concerned with how this is because I haven't used these, whatchamacallits before. Bearing block layout. I haven't used a disc like this before for this, so I'm not entirely sure how well it's going to work, but that's where we're at right now. Do I have M4 lock nuts? I do not. It doesn't look like. Okay, so I'm just going to, one of those things. Well, this is the design as it is. Let's just make it a color. Plastic. What color do we want to make it? Orange? Orange, probably not. With the light blue. Beige. Yeah, it doesn't look terrible. Okay. Yeah, so that's the block. Again, I'm a little sketchy with this eccentric disc, how this eccentric disc is going to work. I think part of it is that I actually need to leave a gap between. Yeah, I'm almost certain I need to leave a gap. I made that hole bigger specifically because yeah. So I made it a shoot. I made it a millimeter bigger to give ourselves space, but it does not look like it is enough. I kind of feel like, let's see, I kind of feel like what I really need to do is take this center and then go off to there. Maybe that's how I need to design this. So let me turn that concentric off. I think that's the concentric I need to turn off in order to get this guy moving. There we go. All right, this guy is now moving. So let us quinky-dink you to this line to make it easier. And concentric on, I circle concentric on this guy instead. And then make you tangent to here. Maybe this is how I need to design it. Let's turn this wheel off really quick to get a look. That wheel, thank you. Okay, yeah, that's probably correct. That is probably correct. And now the only question is, how does that look with the washer? Okay, the washer does cover that whole entire hole. So we should be good. Okay. So that's probably how that has to be designed there. I feel better about that now. Cool. Otherwise, here's our rails. The next thing I want to do is just make those brackets now. And this is another long stream, like last night. Again, I considered when we were at the 1 hour mark with this guy, not this guy over here, but let's see, LM8s. With this guy over here, when we got done this guy and it took a full hour, I considered breaking this stream up. It's just that, frankly, the thumbnail says a little bit of this, a lot of that, as in a little bit of the LM8 and then a whole bunch of this. So, frankly, I didn't want the thumbnail to lie. So we are doing a longer stream now. So let us start a new one of these, and this title, you groove bearing inner slide guide brackets. Save. Open this up. 5mm. Insert. Okay. There we go. So. We are, I think I'm going to take this off here, off the end here, and I'm just going to work off the end. And this is end of rods. We could do the center. Honestly, I could have just used the origin. Yeah, I actually do not have a good reason why I did not use the origin, so we are going to back up and go back to the origin. So here is this. One thing that I started to say earlier and then totally bailed and did not say because other things came up is actually not construction lines. I take it back. Hopefully this keeps this from rocking. I checked the design on the website that we were on when I was showing you stuff, and they do not have bearings running this length. They don't have a race of bearings running this length to ride against the C channel that they use. So that means that they're expecting this not to tip because these things are keeping it from tipping. I guess I'm just going to make the same assumption at this point. So that is that. That is that little bit of information that I was going to say earlier and did not. So let us make this bracket. Again, the bracket should actually be simple like everything else, which means that it will take us another hour. Because, of course. So here, it's here. Right angle, and that right angle should not be necessary because the other three are right angles. So let's see. I'm going to want to project. What if I do body here? That and that is what I believe I want to project. And make these guys construction lines. This is going to have a small gap here. I'm just going to put a 0.5 here just to be greedy. And then I'm going to put a 0.5 between here and here, which is what I wanted this for, 0.5. And one of these deals I could center all this just to save myself the definitions, the constraints. I'm adding some non-verbal constraints for verbal ones. So This is actually just a line. I guess there to there. This should fail, right? Yeah, that did fail. Good. Good, 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 good. This is going to have to go point, please. Thank y'all. There's my center line. That is like that. And this, I think, can just coincidence this, because in theory this should be center. And now this should be 0.5 over here. If math works the way I think it does, it does. And now for down here, we need to accommodate that lock nut that we were talking about earlier. So let me just sketch that in really quick and grab my lock nuts. Lock nuts. M4s are right here, and these guys are how thick? 4.8 rather, not 7, 4.8. Let's call it 5 just to give myself extra space, and then we'll just butt up against that. So this is going to be like that, or not. I guess like that. Please? There we go. So calling it 5 just to make sure that we have plenty of space, and then we can collinear that. And then it is a matter of how thick we want our bracket to be. On the bottom, I will go with 5. Make it chunky. And then how we want this to look. So one of these things, I can toss this in here. I can say we want, 5 in here, let's say. I could do this, just to make it extra thick, extra chunky, as previously stated. And then that slide will be over there. If I make this smaller, then the slide will overhang the sides. It really does not matter as far as I can tell. So it's a matter of preference on how thick we want these walls to be, I believe. Actually, there is one more thing here that I have not considered, and that is bolting this down, because this needs to be bolted down. Over there on the website, they have their holes dead center of the track to mount it, which is perfectly okay. That's the typical thing for a lot of these linear rails that look like this, in the block style, as opposed to the round rod style, like the ride on the rod style. The self-supporting ones have the single line of rows, is what I'm saying, as opposed to the ones that need to be spanned across 2 rods in order to support each other. The point being is that I then have to accommodate for that, for a countersink head in here. The question is, how much do I compensate? Because it really depends on how big of a bolt or screw we want to put in here. The other one said it was M6s, right? So I guess I may as well. Huh. Alright, an M6 is big enough that I'm cool with doing button heads on M6. So I'm going to get the... I know I said it was 10-ish earlier. I'm going to get the actual diameter now for this. Let's check. Okay, 10.15-ish. So we'll put a... Okay, we can go down on this one. So on our other design, on the LM8 design, we had to go up into the rod. Let me just get there so that any of us with goldfish memories can follow. You'll recall that we were tapping, in theory, this rod and screwing upwards into it, so the bolt head would be on the bottom here. With this one, we don't have that problem. We can fit the bolt head up here. So I am going to do that. So I'm going to go 10.25 just to make sure that we have plenty of space. And then the button head thickness here is, let us divine, 3.5-ish, and 3.5 is a little over, it looks like to me, so I feel comfortable with that one, 3.5. And now, actually, why are you, oh, did you not get centered? Whoopsies. Centered. There we go. Actually, this 5 may want to move down here. Does it? Maybe we just want to go 3 down here. I mean, this is a lot of plastic right here, is the only thing I'm thinking. So, I think now at this point, that is it. And I will make that construction line because we're not actually putting that in just yet. So, let us go ahead and extrude this out. Distance, or symmetric rather, and let's make it about 1.5 inches. So we're talking something like 35 to 40. So I'll call it 35. Okay. Next question is, do I offset this? Because frankly, I do want this hole. Actually, we got some kind of issues here. No, okay, we don't have issues. Okay, good. I scared myself for a second there. Supports. I was looking at supports here for printing this block. That is not an issue. We can just print the block. Let me go this way, actually. Whichever way, it doesn't matter. Stop it. There we go. But we can print the block like this. So, there we go. Looking straight down on it. It will be down against the bed like this, and then that circle, that half circle, 3/4 of a circle, 2/3 of a circle, whatever it ends up being, will be printed just fine. So that is not an issue. And the countersink that's going to be on the bottom is not dimension sensitive. You know, it's one of those things we can always clean it out to make sure that, and the bolt can frankly be tightened down into it if it is a little rough. So it is not an issue. So that is that. Again, that runs between there and should be fine. So the other thing I was going to say before I got distracted with the overhangs is whether or not I should come in here and hit this with the open up a little bit. I really want these to be snug into the rods. Again, worst case scenario, what we can do is we can put holes in here and drill into the rods like we were doing with this other guy. We could drill in and tap into the rod to keep it in place. That's worst case scenario, but I want to avoid that if possible. So I don't think I'm going to worry about it right now. I'm going to keep that as tight as possible, and then one of those things, maybe try to come in with a drill bit. So if I come with a drill bit to try to open this up a little bit if I need it, that's going to be a bit messy because of this edge right here. Let me turn this off really quick. This edge right here, when I try to clean this up with a drill bit, is going to cause all sorts of problems for the drill bit. It's going to jump all over and go make a mess. So I don't really want to do that, but worst case scenario, we'll come back, I guess, and just print a new one is honestly what it comes down to. So this is top of floor, outside top of floor, outside top of base. That's probably the best way to describe it. Do we have this labeled? Nope, we do not. Bracket out layout. Bracket layout. This is a bracket. And now I made this so that I can do the countersink for the bolt, the M6 bolt. Turn the body off. Turn it off like that so it's easier to get to. Center this on this. Centered. This is 10.1 I think said I was going to do 10.2. I might have said I was going to do whatever. 10.25 is 10.25 right now. That is my decision. I'm sticking with it. This is 6 millimeters concentric there, and now we can go ahead and I guess I'll do this one at a time. Bodies minus 2.5, was it? I guess I'll find out in just a second. Whoops, Control Z. I wanted to rename this countersink bolt. There's another thing to talk about here, which is technically speaking, this in and of itself is not straight, right? This can pivot around the one center point. I'm assuming that I'm going to have multiple of these, and the rod itself is going to keep these guys in line. We may not like that. We may decide that is a bad idea, in which case this should be 2 holes, and we should be able to fit 2 holes in here. I mean, just really quick, I'm going to double check that logic. So let's look at this. And that, and toss another one in here and another one in here. And this is, let's say, 3 millimeters, and this is going to be equal to that. And that is going to be equal to that, and that is going to be equal to that. And then we are going to tangent that off the edge, and that off the edge. Okay, yeah. So ignore the center hole here. So that would be, these are construction lines right here, just to give myself space from the edge. So that would be the countersink holes for the 2 holes. So that is an option. And may as well just go ahead and do that in a second after we get this polished. Let's just get this polished really quick. Countersink hole. Okie dookies. And really quick, bring that one all the way through. Distance all. Flip. Okay. Turn that off. Double check this guy. This is, okay, that's that. Alright, I have it out. May as well check what the cross flats is. Technically speaking, we don't know whether it's going to be across flats or across points. So let's just call it 7 and be done with it. 7, just so that I can get my constrained sketch, my lock of approval right here on the whatchamacallit. So this was 3.5. This was 3.5 down is the answer, and 10.25, which is what I believe I did here. Yep, that is what I did here, but this needs to be 3.5. There we go. All right, so that is the single countersink. We are going to go ahead and boundary fill that guy into a new component. Select that cell. Okay. 2-point bracket. Just come down here to do the end. Sketch on there. Project out that. Not that guy though. Turn that off. And honestly, I only really need the face. So. Turn the body off now. Toss this line in here, just like we just did. This should all be familiar to you because we literally did it a second ago. A bunch of circles inside of circles. This has an extra circle on it because we also need to do the 6 millimeter, which we weren't worried about before. 6 millimeters. 10 point, whoops, Control Z. 10.25 fingers please, thank you. And 3 millimeters from the edge. That is a construction line, that is a construction line, and all of this is equal, 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 and tangent. Tangent, tangent. And now we can bring these down. Bodies minus 3.5, and all the way. I don't know why I clicked that guy. That was a little bit silly. Distance all flipperooski. And there we are. Just rename that really quick. 2-point countersink holes. Holes. There we go. 2-point bracket. Alright, so this one, again, can be confirmed to be straight. So, for example, if we are going against a level or a straight edge, we can line this up against the straight edge, put the 2 holes in, and then we know that that bracket is straight against the straight edge. With this guy, with the single point bracket, we'll come up here really quick. We need 2 of these. Technically speaking, we can put it up against the straight edge, get it drilled in, but then it's going to twist out of position up until we get the second one drilled in and have the rods running through them. In theory, the rods should keep them straight. However, they are just rods, so they can bend, technically speaking. Therefore, this is not technically as stable as the other one. Now, fascinating thing is happening right now. Where is my countersink hole? Huh? Yeah? Okay, there it is. That was silly. Silly fusion. Okay. So, 2.5 hour stream. There we go. This was supposed to be a fun little stream that got done really quick, and that did not happen. And that's okay. A couple things to mention at the ends here. In theory, this can just run off. If I wanted to, I could design one more of these guys, which is capped at the end, so that it can't run off. Otherwise, you can obviously just add a cap to the end. Just any old piece of material at the end will stop it from falling off, so that's not that big of a deal. I'm hoping this eccentric ring works as I expect it to. I will be very sad if it doesn't. I will be printing out this model as previously stated because this one is affordable, unlike the LM8UU, UUOP, whatever. So this guy, until I decide that I feel like doing something expensive, will be staying as just a dream. However, it is a model that we can look at and go, ooh, ah. This guy, though, I will do a follow-up stream probably, or a project update stream more likely. I'll probably do a project update stream of a couple different things and include this guy in it once he is built. So look forward to that guy. Otherwise, if, well, before I sign off, obviously, this is taking a good bit longer than I expected. And one of those things, it is nearing on dinner time. And again, post-dinner, well, basically point being is that I'm pretty sure at this point that the coiler uncoiler code is not getting, at the very least, not getting fixed after being tested today. I should hopefully get to the point of testing the code, but I don't know that I will have it completely fixed for an after dinner stream to actually demonstrate it on stream and go over the code. So again, probably most likely if I do stream after dinner, it will be a game stream. So look forward to that guy. Otherwise, as always, thank you for watching if you have been, and I hope you have a great and wonderful day, afternoon, or evening, wherever you're at in the world, and I will catch you next time.